Thank you all for joining. My name is Robin Kleine. I'm a consultant at Mobicon. And with me is Deodat Boer from Cycle Data. And we're going to talk to you about cycling data, of course. And you already heard of some of the projects in Boca. And we'll be mostly sharing examples from the Netherlands, from Europe. So I will start the presentation. At some point, Deodat will take over. And we should have some time left at the end for Q&A. And if you already have questions, comments, I think the way to go is to leave them in the comments for now, and then we will get to them by the end of the presentation. So let's see. Yeah, so before we dive into the examples, why even think about cycling data? Why should we even, why is it important? And the thing is, it's all about being visible in a digital world. I guess it's not really surprising for you as well that the volume of data is increasing. This is something that has been going on for a while, and that will keep going on for a while. And the same thing goes for mobility data. And well, the data actually has an impact. For example, we use it in our models, we use it in all kinds of analysis, which on their turn impact the policies we have, the investments we do. We use data in our traffic management systems, which basically directly gives some people priority over others. And we use data in all kinds of products and services. So, for example, travel planners, and these products and services influence behavior in that area. So yeah, data has an impact. And the thing is, there's not a lot of cycling data. So this is a worldwide thing, even in a place like the Netherlands or other places in Europe, cycling data is quite lacking. And it makes sense that is the case because, well, cars are basically driving computers nowadays. Loads of cars, loads of data they collect, and that's being used, it's being analyzed. Yeah, so there's quite a lot of car data, whereas a bike in its nature is not much more than a piece of metal and some rubber. And yeah, we don't have that much cycling data yet, therefore. Luckily, we do see more and more opportunities in terms of cycling data. I clustered them in 3 categories for now. But there's different ways of collecting data from the infrastructure. So either about the infrastructure or using infrastructure-based methodologies. For example, like the radar system from Cycle Data, or camera systems, or some of the things you've seen in the presentation before, the traditional tubes and stuff like that. And then the cyclist can also be a great source for data. So yeah, mostly smartphones, smartwatches, stuff like that. They can be used to collect all kinds of data, and therefore the cyclist can be a source himself or herself. And then, of course, you can use the bike to collect data. So yeah, for example, by adding certain sensors to it, that in the top example, they added Bluetooth sensors to bikes, which gives them priority at certain places, but also tracks them and gives them route advice. But you also have whole devices that measure the quality of the pavement, stuff like that. So that those are other examples of how you can actually collect data using the bike itself. Yeah, to show you how we what we then do with the data, I would like to show some projects we work on. Of course, it's nice to have the data, but eventually you got to use it. So a quick overview of things we do with it. We use cycling data in policies, so to inform cycling policies, action plans. We use it in network development. We use it to develop and execute monitoring plans, road safety assessments. We do data visualizations and interpretations, so basically making the data available to certain audiences in the right way. We implement all kinds of digital products and services, or help to implement them, find the right products, contracting, things like that. We use it in our workshop and participation processes. And last but not least, but we use it to inform the design of roads and public space. So yeah, in the end, it's about how you use it. And a topic I would like to dive deeper into with you guys is cycling potential, because I think it's a quite interesting one. And a trap with cycling potential is that we often equal current use to demand. And so we measure that there's not many cyclists in a certain place, and then the conclusion is, well, apparently people don't want to cycle here. And that's definitely often not the case, and that's obviously because conditions matter as well. So if conditions are bad, people will not cycle. And I really like this image as it shows that on the left, conditions are clearly not very good, people don't cycle. Well, but if the conditions would be better, this would actually be a good connection. And yeah, this is something to take into account when working with cycling data, that what you see now doesn't have to say something about tomorrow or next year or how it can be. And to show you then what you can do to, what an example is of how to deal with this and how can you look at the potential, I want to share a project in Tbilisi. So Tbilisi is the capital of the Republic of Georgia. I think it's literally on the other side of the world from Florida. But it's, yeah, it's a place with virtually no cycling, almost no cycling infrastructure. The infrastructure that you have looks like the one in the picture. So it's mostly being used for parking and all kinds of other purposes. It's a city of about 1.2 million and growing, and maybe even a bit bigger because of unregistered inhabitants. And it's about 200 square miles, and they face quite a lot of probably familiar challenges in terms of congestion, the environment, air quality, health, etc. And basically their question is, where can we start? We want to promote cycling to combat these challenges, but where can we start? There's almost no cycling data because there's no cyclists. However, they do have a mobility survey and some spatial data. So we used the survey to, the mobility survey, to say something about the potential. And what we did is we looked into the distances that people travel and the modes they choose on each distance. And what stood out is that people generally walk up until about 2.5 kilometers, or I think that's almost that's about 2 miles, maybe a bit less. And over 2.5 kilometers, so larger distance, everybody will choose the car or public transport. So that's a place where there's definitely some potential for cycling. I mean, that's a typical cycling distance where if conditions are right, people will choose the bike. And something else that stood out is that they have quite a large use of public transport. So public transport is even more popular than the car in that area. So based on that, we dug a bit deeper into multimodal opportunities, like what kinds of public transport would be best fit to connect to the bicycle network. Is it the rail system? Is it the metro? Is it BRT, cable cars? And where is the biggest win if you increase the catchment area, basically? What kind of target group can we distinguish? Yeah, who are the inhabitants of Tbilisi and how do they travel? And we calculated some mode shift scenarios. So if we change this and this, and we expect this behavior change, what would the effect be on the total, and what would be the effect in terms of CO2 reduction, for example? So things like that. So actually, with zero cycling data, but some general mobility data, there's still quite a lot you can do, and some interesting insights you can generate. So based on this, we work towards a strategy. And then it's got to be more specific. What are we going to do? So we analyzed the short trips. So those 2.5 to 5 kilometer trips. Where are they? From where to where? Yeah, what do we see? Where are people moving? What is the current mobility demand or the total demand on this trip length? We combined it with some existing data about topography, about important destinations, things like that, generally available data. Did some workshops with local stakeholders to discuss routes, to discuss pairing opportunities, to basically see how we can make it happen. And altogether, this is what is based on what we're now making what we call a data-informed cycling plan. So basically a specific action plan based on those data, but also based on well, loads of other things. And why do we call it data-informed? I think it's basically a variant of data-driven. We hear a lot about data-driven, and essentially it means that you use the data to make decisions, which is very good. And I think data-informed is a very important alternative or variant where you use the data, you use it in a wise way, you use what you can get, but you also use your own knowledge, you use context, you discuss it with each other. There's even room for your gut feeling, everything basically. And I really like this way of working because often you'll find that you don't have the exact data you want, and then you got to be smart with what you have. Yeah, so far about the example in Tbilisi and how you can think about the potential for cycling based on survey data. The last topic I would like to discuss with you is digital products and services, and more specifically the BITS project. So BITS stands for Bicycles and Intelligent Transport Systems. It is an EU co-funded project. It is a cooperation between 13 partners from 5 countries, being Belgium, Germany, Denmark, the Netherlands, and the UK. We are providing the lead partnership for the province of Overijssel, and Deodat and Cycle Data are also partners in this project. So this BITS project is basically the first large-scale rollout of ITS in cycling. We have a quite broad definition of ITS, so it means that there's a technological aspect to it. And the thing with ITS is basically that they need data, so they function on data. And because of that, you also have opportunities because you can use the data probably for other things as well. And for example, to learn about bicycle use or to somehow inform your policy or create new products. So what we try to do in the project is to collect, process, analyze, and share that data through what we call the Cycle Data Hub. It's a website, you can look it up if you want to. Still working on it though, so yeah, it's in progress. And we're also working on the Products and Services Directory, which is basically an online marketplace where we kind of connect the market and the demand. So yeah, to make sure that everything that's available is easier to find and that people find the products they are looking for. So I brought a couple of examples from the BITS project. And first one is apps. So we got a couple of apps in the project. And these apps are typically travel planners, and they can also be rewarding apps. So you get a reward for every kilometer you cycle. And these apps function on GPS. So they need your location to know where you are, what the best route is, etc. And so it collects a lot of location data. And this data is on the one hand being used to inform the riders. So the people who use the app get feedback on the kilometers they cycled, on the days they cycled in a row, or yeah, it's just kind of encouraging feedback. And that same data can also be used for policymakers. So by combining all these individual routes and trips, basically, you can get a pretty big overview of cycling behavior, and more specifically the origins, destinations, the speeds, the routes people choose, where they encounter delays, also the routes people do not choose, which is maybe even more interesting. And if you combine that data, for example, with counting data, you can get a pretty complete overview of how your cycling network or how your total network is being used. So pretty interesting data source, a lot of progress happening in the Netherlands as well with this. Another one are smart cameras. I think somebody in the introduction also talked about that they used it in Florida already. So cameras that register traffic, and then these same footages can then be used to analyze with special software. And what the software does is analyze near conflicts. So based on where people are, who they are, what kind of vehicle, their speeds, it kind of calculates if something was a near accident, so if it almost went wrong. And by doing so, you can get a pretty detailed insight of how, for example, junctions are being used, where dangerous situations happen. What is wrong with them, instead of having to wait until it really goes wrong. And in this example, this is in the city of Antwerp. And they actually thought they had to reconstruct the whole junction, but it turned out they could quite easily solve some of the major problems with it. So it turned out to be very cost efficient to do it this way. Another interesting data source can be shared bicycles. So this is a bike sharing system from one of our partners in Overijssel. And they basically have three data sources. So first you have the app, which you use to unlock the bicycle. But of course, it also collects some data about where you are, about who you are. Of course, privacy issues, privacy is considered. So that you cannot do everything with all the data in this case, but nevertheless. There is an electronic lock on it, also with GPS and Bluetooth, because it needs to know where the bicycles are, so you know where you can find it, but it also collects data on where they start, where they go to, how long it takes, etc. And an additional thing these bicycles have are sensors for air quality. So they also collect data on the air quality, which can then also be used, for example, to inform people about clean routes or to monitor the air quality in general. Then my last example, this is a bike library in the UK, in our partner, the East Riding, so it's Yorkshire. And what they did is they organized a bike library where people can borrow all types of bicycles, special bikes, normal bikes, whatever they needed. And these bikes were equipped with all kinds of sensors. And what they did with it is basically two things. So people who joined this and who borrowed a bike got coaching. So people who if they needed training, if they needed any kind of coaching to get them cycling, that is provided. And these coaches are then informed by the data that the bikes generate. So if somebody cycles every day, 3 weeks in a row, and suddenly stops, then that's kind of an alarm and maybe a reason for a coach to give a call or to discuss it during their next meeting or something. So the data is being used for the coaching program. And at the same time, the data is also being used by the municipality because they collect data on, well, again, locations and stuff. But in this case, also from sudden breaks, dangerous situations. And that's all being used to prioritize investments and create a cycling network over there, because at the moment it's not really existing yet. There are many more examples from the BITS project. For now, this is my last one, but Deodat will continue with some of the work they are doing there. So I would like to give the floor to Deodat.
Thank you very much, Robin. So this is the example 5. I will go on with the examples from the BITS project. This is where cycle data is joining. What we are doing is giving priority to cyclists by detecting them in front of the traffic lights, so they don't have to wait long or don't have to wait anyway. It's all detected in the middle with the radar laser combination. I will tell you more about it later. Then also we connect, we change it to a smart access point to measure or detect other stuff like air quality, sound quality, and all kinds of stuff. And also we, in the same project, we are working on to detect the volume of the bike. So we know if there is a kid on a bike passing, or there is a cargo bike, or a moped, or a racing bike. Because all those different types of cyclists have different impact on safety. So this is so far the BITS project. I want to go on, but it looks my screen stops. I'm sorry. My presentation. Oh, there we go. Yeah. So what we do from the cycle data is what we have is a radar laser combination, and this is different from the tubes or from camera using. We don't want to use cameras because we have a lot of privacy issues in Holland, so we don't want to go there. But we also found out that with a combination of a radar laser, we have the best accuracy. And when you have 100 cyclists in a day on a cycle path, it doesn't matter so much. But when you talk about 10,000 or 20,000 cyclists on a day before COVID, we want to know exactly when they are passing, which direction they are going, what time they are passing, and what the speed is. So this is what we are able to detect. This is a kind of system we take care of it completely. So the government doesn't have to do anything. They just have to tell us where to install it, and then we put it there, and then the whole thing is working. It's powered by a solar panel, so no electricity is needed. We always put a sign on it. It says fietssteller. It means bike counter, so people know why the system is there. There's also it's also the combination with a smart traffic light. As I said before, it's almost the same system. There's a signal going to the smart traffic light, so it knows how many bikers are coming and what the speed is, and then it can respond to it by giving them green light immediately or soon. We also can add some displays so that people know that they are counted and they know what the counts are. We found out that this is stimulating for people because they want to be seen as a cyclist. This is the dashboard that's behind the system. So it's possible to have almost a real-time visibility of what is going on. The location is always visible. On the top left, you see all the data itself. There are some graphics in the system, so you can immediately use it to see what it means, what the data means. So this is the system. On the vertical lines, you see the days. It's connected with the weather, and on the horizontal lines, it's per hour. You see the number of cyclists that are passing. You can segment it by speed. So, for example, if you want to know how many cyclists between 10 and 20 kilometers an hour or miles per hour, then you know what kind of bikes they use. If it's if it's more than 20 kilometers or more than 30 kilometers, you know it's a moped or it's an e-bike. You can segment it by the direction, but also you can see it change the segmentation, so you can see it every 5 minutes or every 15 minutes or half an hour or 60 minutes. And it's you can take out a CSV report of all individual bikers and the time they're passing. Also, so yeah, well, Robin also told about it. What are the reasons? Why do you detect data? Well, here are some reasons why what we found out in Holland is to understand the trends about safety. So when it's busy, you want to know when it's busy, because that's are the moments that most of the cyclists are coming at the same time. But also to understand the travel patterns. Sometimes you need to change infrastructure, because you know there are lots of cyclists, or not that much. If you know how many bikers are coming, then you know also about how many parking places do you need, or are other things that you can add to the route, or that kind of stuff. But also to evaluate the impact or develop transportation models. If you work with models, when you know the amounts that are coming now in passing now, if you change in the model the amount, for example, double it, you have also the possibility to see what is the impact on infrastructure around. So what does it mean if you have much more cyclists at that route? What means it for the other infrastructure in the neighborhood? With the intelligent smart traffic light, you're able to give priority or a green flow. You have much less people who violate the red light. That what we see in Holland. When you give them, then they don't have to wait that long. And well, with COVID, you don't want to have too many people at the same place. And also it's preventing cycle jams. Well, in Holland, that's quite usual. I don't know how it is in the US. Here are some ideas how you also can use this our system. What we did in Holland is rewarding every 100 cyclists with planting a tree. What happened is that more people were using the route, and people were more often cycling, going on a bike. So it's still the same system for data generation, but also you can use it for promoting cycling by taking a certain route or something like that. It's also what we also can do is to measure what the costs are of when cyclists have to wait at, for example, traffic lights. In Holland, it's very usual to we exactly know what the costs are for cars when they have to wait for traffic lights or in traffic jams, but we don't know that for cyclists yet. But now we can compare it to each other, and that means that you can also give priority to cyclists when there are more cyclists than cars. There's also the bike scout. We call it the bike scout. That means that when the cyclists are coming in, when they cross a car road, you can looking for the word. You can warn the cars that cyclists are coming at the moment they're passing. You can do that by display or by using lights in the road or something. And at the same time, you're still generating data for it. This is quite a difficult system. It's still Dutch, but it's also possible to use it in the US, because we have made a kind of system where we can measure when it's still safe to cycle with, for example, 200 cyclists at a cycle path, because we know how many what the width is of the cycle path, and when you need to know how many cyclists can cycle the safe before it's too narrow. Well, it looks quite complicated, but it's a system where you just put in the numbers and the percentage of people who are going one direction and then it comes out if it's safe or if it's not safe. And well, that's how you can prioritize to change infrastructure if needed. I told you a little bit about the innovations we do in the BITS project to measure the volume of the bikes and to detect noise or air pollution. And all those also these results are visible in the dashboard. And well, as we have seen the El Rio trail, some of those things are quite easy to use there. All right, I'm at the end of my presentation. Thank you very much. And Liz, are you there to moderate the rest of the session?
I'm here. Can you hear me?
Yes, I can hear you. Okay,
great. We had quite a number of questions that I think we can start with. The first one is, and I kind of put a little bit in the chat about this, but love to hear your comments as well, is do you have data already for trip generation based on land use? And I just put in the chat pod, you know, the data that FDOT is collecting is great calibration, highly accurate, statistically valid volume data that can help in being the input for modeling software. But if you two want to mention other things that you're doing, that'd be great.
Yeah, I think that's true, of course. So you can use that data combined with counting data, and that's, I think, what's being done in a lot of traditional models, which works pretty well. I think I personally also very much like to use that kind of survey data, because when you look at cycling, it's also very important to consider the distance. So the origins and destinations where people want to travel to is very important, and especially when you look at cycling, the distance becomes important, and you can use those kind of surveys, for example, to calculate a distance decay curve. And if you combine that with the counting data, with the zoning data, then there's a lot you can do. And if that's not all available, then there's various ways of doing it, but yes. Did that kind of answer it?
I think so. Are there others that wanted to make other comments on that? If not, we have a couple other questions. The next question was, what is your experience with e-bikes in cities? We have problems with speeding, running into pedestrians, riders on sidewalks, and increase in accidents.
Yes, yeah. I think we know that problem. We also have that in Holland, especially in the big cities. Sometimes it's really dangerous and it's difficult to come with solutions. But we also know, because it's so dense in the cities, is that the e-bikes, the speed can't be that fast because it's too busy. On the other hand, there are some rumors now that they want to put a maximum speed on bikes in the busy areas, but it's very difficult. Maybe you know anything about it, Robin?
Yeah. Well, I think in general the e-bike development is not per se a negative thing. I think it's great that it allows more people to cycle longer and further distances. I know there's also research showing that it's actually just as healthy as using a normal bike. So even though some say it's lazy, apparently it's just as healthy. And I think one of the issues in the Netherlands also is that it's mostly being used, or not, well, a lot of older people also use it. So people use electric bikes to be able to cycle longer, but older people are also generally, a bit the easier get into accidents, fall and things like that. So that also makes it a bit more dangerous. I think in the cities, it's a general problem that the diversity on the cycling paths is increasing. So you have normal bikes, you have e-bikes, a lot of delivery e-bikes, cargo bikes. So it's a general challenge that it's becoming more and more busy. Differences in speed also matter, and especially if you look at speed pedelecs. So like normal e-bikes go up to 25 kilometers an hour. I'm not sure about miles, I guess 20. But speed pedelecs can go up to almost twice as fast, and that's when it becomes really challenging. And that's why the law now says that speed pedelecs have to use the roadway where cars are as well. But that's also not ideal. So we're struggling with that as well. However, I would also say that if you look at violating rules and using the pedestrian areas and stuff like that, I think that those problems are limited where the infrastructure is good, but we're also facing the challenge.
Okay, other comments? I think we have one more question. Could this technology be used to identify motorcycles approaching a signalized intersection? This would help advise large vehicles at the intersection that motorcycles are in the vicinity to be more cautious on their lane changes or backing up, thus to reduce crashes where trucks hit motorcycles because they were not visible to the truck drivers. So line of sight kind of question there.
Yeah, well, if you mean to use the technology which is cycle data using, it's not possible to use it for motorcycles. We only can detect bikers and pedestrians when they're walking and cycling in the same direction. So I don't know.
Most video detection, vehicle video detection will detect motorcycles. I know here in the city of Boca, we use all of the video detection we use all detects motorcycles. So probably the worst detection for motorcycle detection is loops. We've found video detection, the infrared, the radar, all the stuff we use has no problems detecting motorcycles.
Can you state who is speaking, just so we know?
I'm sorry, this was Tracy.
Okay, Tracy, thank you for your comments. Yeah. We also, I know in traditional motorized counting technology, you know, with the speed, the distance between the axles, you know, this is how we classify things. So even if the technology is not there today or readily available, it's very close. And I like your comment about the video technology because you can capture a lot of different modes and different things. So we're getting there. We want to count everything. Everything needs to be accounted for, and hopefully in the future we can collect more data that can really classify all these different types of devices that are out there for travel. So another question came in that's real good related to our conversation right now, and that is, are e-bikes considered motorized?
Yeah, they are not. If they're limited to 25 kilometers an hour, so 20 miles. If they are not limited to that speed, then they are considered mopeds or the same category as mopeds, for which you need a driver's license, you need to wear a helmet, and you need to use certain parts of the infrastructure. So in my city, for example, in Utrecht, you're not allowed to use the bike path, and actually in most places, you're not allowed to.
So I can also speak to the Federal Highway Administration considers e-bikes as micro-mobility, which is that bucket of non-motorized, which traditionally has been non-motorized. So I think it's an evolving term. It is an evolving accountability and counting technology, and it's getting there. I will say that the Federal Highway Administration just updated the Global Traffic Monitoring Guidebook, which is the guidebook that the federal government puts out on how to do counting and how to classify. And one of the most significant and impactful changes that was made to that document was to integrate micromobility inside of the motorized counting. So now it's all weaved together, as though if you're building a program, it shouldn't matter whether it's motorized or non-motorized micromobility. All of the data should be handled similarly, and in places within that document, in places where references to micromobility are a slight bit different, some of these nuances have been called out. We put a lot of, Federal Highway put a lot of call outs so that they would highlight the differences between motorized and maybe non-motorized data. So I don't see any other questions in the chat pod, so not sure what we're supposed to do now. We have 30 minutes, so if anyone wants to take themselves off mute and ask a question, that's okay too.
Hi, this is Victor, FDOT Traffic Data Collection Supervisor. I just want to say this was a very good breakout session, and I was able to obtain a lot of information on how the Dutch obtain their data and use of their data. So we're hoping to incorporate some of your practices and procedures into our program to make one of the best ones in the nation. Thank you, everyone.
I want to reiterate, this is Kara Schwartz-Devena with DOT. Yeah, I agree with Victor. This was a good session, breakout session. I do agree. We do have a hand raised. Jesus Fuentes has his hand raised.
Question. It's how to translate the data collected to make it so when we implement policies, we have support of the public. Because the battle that we usually have when we're implementing bicycle infrastructure here, especially here in South Florida, is that people interpret empty bike lanes as, you know, wasteful use of federal dollars. And they don't relate that the bike lanes are empty because they're efficient, because people are moving faster and therefore there's no congestion. So once you collect the data, how do you, I don't know if you can provide some kind of guide to for us here on this side of the pond to kind of translate that, so to gain hearts pretty much from the public, because sometimes the public is very against implementing this type of thing because they see as a waste of taxpayers' dollars.
So yeah, thank you. If I understand well, the situation is that the bike lanes are being used, but they seem empty. And how do you deal with that? So
correct. It's typically, we don't have that the situation where you have a, maybe not here in Florida, probably in California or in Oregon, where you have a more robust bicycle coalition. But here we don't have that type of 40,000 cyclists on certain locations per day. So when we implement, especially when we are implementing bicycle infrastructure, then a lot of the neighbors, residents, they say, well, why are you adding a bike lane here in front of my house? It's a waste of taxpayers' money. Nobody rides a bike. I always see them empty. You taking space away from the cars. I know it's a little bit more towards, once you got the data to support this type of improvements, how do you present that so it's more amicable for the public to digest and be in support of more bicycle infrastructure improvements.
Yeah. So before actually implementing, so to yeah, it's challenging. It's basically something we see everywhere we go. So when we tell how we do things in the Netherlands and people are enthusiastic, we often get the question, well, that people don't believe it here. People think it's a waste of money, it doesn't work here, it's different here. And I think the good thing is every time projects actually happen and investments are made, it turns out that it wasn't different there. But yeah, it's hard to convince people from that beforehand. I think what we like to do and what helps is yeah, very clear communication and also showing the impact. I think I saw in the introduction presentation something about a bike counter that also gives feedback, like your number this 100. I think things like that are good, and also translate what it means for example, the environment, what it means for people's health, what it yeah, what impact it actually has. Also, what would it mean for traffic if there wasn't anybody cycling? Yeah, how many people would then be standing there? And I think in the end, it will always take some guts to do things and deal with the resistance that there is. Luckily, we found that in most of the times it turns out well, and people eventually are pretty happy with like, yeah, slow traffic, more pleasant spaces in front of their house instead of a dirty motorway.
Yes, and if I may add, in my hometown, there was a kind of the same problem. There were lots of kids were crossing the neighborhood all over, and that was dangerous. And so the government decided to create a new cycle path, but they didn't know if those kids were going to use it. They had guts and did it, and they measured before and after. So before there were only the kids were going all around, and after that all the kids were going at the same cycle path because it was going faster and it was safer for them. And it went out that more than 2,000 cyclists a day were passing, and that was quite a lot for my town. So it has to do something with guts and data, because you can measure before what's going on and you can measure afterwards. So with the data, you can also convince people that was a good decision.
And I'll just add some experiences from a national perspective, and that is, you can make change happen if you get the right people involved. So you have to have the champions. Particularly, I'm going to give an example in Colorado with snow, but translate that to Florida and sand or water or anything else impeding the facility, so that cyclists are actually not on the roadway or on the trail because of snow. But it could be sand or water. And what happened was we did some counting in Colorado where we showed that before one snowstorm, there's no travelers on the trail. And then a second time we plowed it, and then we compared the data from plowed versus unplowed. And that actually effectuated change at the operational level, to the point where they saw the numbers were over 100 facility users per day, even in the worst of snowstorms. That helped them change their policy such that they would maintain the facility 48 hours after the last snowflake. They now plow that trail. So it's just one example, but it's really key to get the right operational people that are already maintaining and managing that facility involved in the numbers that are being collected. So do we have any other comments on that? We have like, I think 3 or 4 more questions that came in, so. If not, we'll move on to that next question, is about, do you have any experience with public information campaigns regarding best practices for safety, etiquette, and awareness?
Yes, as I talked about every 100 cyclists that were passing by, where there was planted a tree that was kind of rewarding the people. So what happened is that what we usually see when there is a display or a countersign is that people like to be counted, so they take that route. But also when there is a reward for the environment or for a school or whatever, that's where people are increasing their usage. So in Holland we see that it works.
And maybe to add to that as well, if you're talking about like more safety aimed trainings, of course it's important to educate the cyclist, but it's important to educate everybody that's part of traffic. So yeah, it's also about informing motorists and learning them how to deal with cyclists, to be aware of cyclists. Something we do a lot in is also children. So children going to school. Yeah, of course you need to teach children how to ride a bike. You need to teach them when to be extra aware, how they do not fall, how they stop when something is not safe, stuff like that. To watch left, right, left, and well, do everything well. You need to know the traffic rules, but you also need to educate parents, for example. To tell them on how they can practice together with their kids, yeah, things like that. So there's a lot being done in that sense, luckily, because it's very important. And I think the most important thing is that it's quite you need a broad perspective. Like, it's not just educating the cyclist.
I liked what you said, Robin, at the beginning about it's really education. It's constant. When you're a traffic professional, you're always trying to explain the numbers and educate people about how that data was collected and the proper usage of that data. So I think, I'm not sure if the question was really more of the outreach programs, but every DOT typically has a bike, campaign within all of the states within the US. And there's a lot of outreach and education done with the users of the facility, but there's also the education of the traffic data itself. So so there's a couple of ways to answer that question. So we have another question that came in, and it says, what has been your experience with visible counter signs? Specifically, do they add to the riders' buy-in or increase usage?
You have these, right, Deodat, or?
Sorry?
You have these kind of products, right?
Yes, that's what I meant with my question, with my answer before. It works. It really helps for it's almost the same with cars. If you want to speed them down, you can give them signals by a display that works. If you know people are being seen as a cyclist, that's already a reward for them. But also if you reward them with something else, what you can add in the neighborhood or whatever, that works. Yeah.
I mean, it's a great tool, definitely, to market the counting program. I will tell you that it's been super successful in helping expand counting operations. It's been super helpful in expanding within different departments, within operations, within cities and counties, and state entities that are already doing counting. Adding that gives them they're usually back behind the scenes, but it puts them in front of the traveling public in a positive way, where, typically if something's not going right, sometimes we hear about that, but in the case of the display boards, it's kind of a really positive thing to see how many of the traveling public is using the facility. So, and the exciting news, if Eric were in the room, would say that there are at least one public display counter in the state of Florida and a couple more coming soon. So this technology is already making its way around Florida in completely different regions of the state. So.
Yeah, we just recently did a pilot in Holland with planting trees for every 100 cyclists. The government had reserved 200 trees for this project. It turned out that they had to plant 530 trees because so many cyclists were using the cycle path because they knew they were going to plant trees. So I talked to a lot of governments and they are really enthusiastic about this concept because in Holland they are creating all kinds of bigger and fast cycle path to connect cities, and we have a lot of wind in Holland, so putting trees or bushes at the side of a cycle path can be very helpful for them, and they can use it as a kind of reward, so it will promote cycling at the same time.
And then I think I skipped a question that I'll come back to, and that is, how do you get a town or a city started on collecting data? Great question. What do you think about where to start? What are the most important data points to persuade policymakers to pay more attention? And I would say to the very quick answer to this question, and then I'll let you guys answer, is all the same reasons for motorized data and more, because cyclists are not bound and pedestrians are not bound to a facility or a roadway, and they can do lots of different things that a big car cannot do. And to get them started, typically, I will say every city, county, state agency has operational people that are already doing motorized counting. And the easiest way to get started is to educate folks on how that skill set that they're already doing translates over to the non-motorized or the micromobility side, and how you don't necessarily need a ton more resources or a lot more money to just get some counts started in a program. So, and then there are of course really good literature out there that has been published that could be helpful. Attending these webinars that Eric is hosting, and FDOT continues to invest in putting together these webinars for educational purposes so that these kinds of questions can be addressed. That's very critical in helping cities and towns. And if you don't know about the loaner equipment program that FDOT currently is managing, you should ask about that as well, because that's another way to get cities and towns to do collection with free equipment that FDOT is supporting throughout the state of Florida. So those are some really good ways to get started. I could probably talk for a very long time on this, but I'll let you guys answer how that might be happening in the Netherlands.
I was going to say, this is Kara with DOT. Let me jump in real quick. I'll put my information, my email, my phone number for my office in the chat. So if anybody that's in District 4, they can contact me on setting up anything or getting on the loader program. I can assist them with that. So I'll put my information in the chat. And Eric did give us a 5-minute, so we got about 3 minutes left.
Great.
Yeah, of course, very much support the answer to use the support from FDOT and get started like that. I also think it's good to think about what do you want to know exactly, because you're collecting the data for a purpose. Do you want to develop a network? Do you want to substantiate investments or campaigns? Well, it depends on what you want to do, and then there's loads of ways to get started. And I think one of the counting and it's a very good way, a very reliable way. I think there's also a lot of new opportunities that you can also think of depending on what you need. So the ones I also dealt with in my presentation. I personally also very much like the surveys because they're often available. I think the census you have offers some same kind of data which you can dig into. So yeah, a lot of possibilities really. And I think it starts with thinking about what you want and what you want to get out of it.
So I think we can end with one last really good question that came up was, can we classify pedestrian count and bikes counts if they are sharing the same sidewalk, and what technology is used? I will just quickly say before we're done here that typically, yes, you can classify between pedestrian and bicycles. There are typically a couple of technologies required to do that. You can use tubes for bicycles. You can use infrared for all of the travelers that pass the counter, and then you subtract the two to get the pedestrians. So that's one really common scenario for technology that's used to classify the two. And did you, Deodat, want to give more information on that?
Well, I already answered in the chat to the question of Jose. So, but it's doable. It's with the cycle. Oh, it looks like we have to close.
All right.
Yeah.
Well,
We're getting redirected back to the main room.
Yes, thank you, everyone. We'll be reconvening in the meeting room so shortly.